In this lesson, we're talking about reflections, and we've delved into reflections before, but we're going a little bit deeper into it in this lesson. So we're starting off just doing a reflection on tracing paper. So in part A, they say draw and label a line L on tracing paper. And draw and label a quadrilateral ABCD with vertex C on line L. So A, B, C, D. Then they're asking us to fold the tracing paper along line L. I want to make sure I'm actually doing this under the camera. And when I trace the quadrilateral, almost like magic, you see there's a little impression of it left on the other side of the line. So I'm going to darken that. And this is B prime, A prime, and D prime. Then they ask me to draw the segments to connect each vertex from quadrilateral ABCD with its image. So connecting B and B prime, connecting A and A prime, and connecting D and D prime. And they're asking us what we notice. So maybe some color would be helpful. Whoops. They're asking us what do we notice about these three segments that we've drawn. And what I hope that you would notice is that they're all parallel. From A to A prime is parallel to B to B prime and C to C prime. Let's call these segments. Then it asks us to use a ruler to measure each segment and the two shorter segments formed by the intersection with line L. So what they're wanting us to notice or measure is, since B to B prime is getting cut by L, it's forming two segments, this piece and this piece. So they're asking us to measure those lengths. And I'm going to use centimeters because these measurements are kind of small. So that's 2 centimeters, and that one is also 2 centimeters. From A to the line is 3 centimeters, and from the line to A prime, oh, that's also 3 centimeters. And then finally, from D to the line, that's about 1 centimeter, and same thing in the other direction. So what do we notice in that part of our explore? We notice that line L is cutting A prime, B prime, and C prime into equal segments. Here they're asking us to reflect upon, pardon the pun, to think about what happens when a point is located in the line of reflection. So in this diagram, remember that C was on the line of reflection. Notice that it didn't go anywhere. So that's an important observation to make. In this activity, the fold line is the line of reflection. What happens when a point is located on the line of reflection? It reflects onto itself. And then we're going further in graphing into, or reflecting in graph paper. So before we can do that, there's a little bit of vocabulary that we need to clarify. Notice here that we're talking about the definition of perpendicular lines. Perpendicular lines are lines that intersect at right angles. You might want to highlight that in your notes. And in the diagram, notice that they've drawn L and M to be perpendicular. Notice this little box thing here. That indicates that the lines are perpendicular. So if they want to tell you that lines are perpendicular or that there's a right angle, they'll use that little box to say it without saying a word. The next vocabulary that we're looking at here is a perpendicular bisector of a segment, which I know perpendicular now means they're intersecting to form a right angle. And I've mentioned previously that the bisector of a segment passes through the midpoint. So in this particular diagram, because N is dividing segment AB into equal parts, line N is the perpendicular bisector of segment AB. One thing that I may have neglected to point out in Module 1 is these hash marks and their significance. Those hash marks are telling you that if I called this point X, those hash marks are telling me that the length of AX equals the length of XB. So now finally I can use this vocabulary to build a precise definition about what is a reflection. Okay, so if a reflection maps a point P to its image P prime and I'm reflecting it over the line L, notice in this diagram, is the perpendicular bisector of the segment formed by the pre-image and the image. And then we talked about earlier how when a point is on the line of reflection, it's going to stay in the same place. So in the next example, they've gone through a whole reflection for you in the coordinate plane. But we don't have any numbers to go on. We're just kind of using the grid lines. So I'm asked to reflect triangle ABC over line L. And the instructions are saying to draw a segment with endpoint A so that the segment is perpendicular to line L. Now, they're going on the assumption that you remember from algebra what it means for two lines to be perpendicular. And what it means is that, let's notice that line L has a slope of -1, because every time I am rising one, let me start over here. Every time that I'm rising one, I'm running -1. Okay, so the slope of line L is -1. And what you need to remember from algebra is that slopes of perpendicular lines have a product of -1. Okay, so I need the slope of a to a prime. It's going to be a number, and I need that number to multiply by -1 to get -1. So that's why you see that the slope of a to a prime is 1. So from a to another point on a prime, I'm rising 1, running 1. Okay? That's information that the textbook is assuming you understand. So that's why they were able to draw this perpendicular line. And then it says we want to make sure that it's bisected by line L. So you could almost use that same rising and running to figure out how far you need to go in order to get to A prime. So here's what I mean by that. From A on this segment to the line, I have to rise to, run to. So I do it again, and that's where A prime is. And then they're doing the same thing for points B and C. In part B, now they're saying do it on your own. Okay, so once again, step 1 is to draw a segment with an endpoint at vertex A so that the segment is perpendicular to line L and is bisected by line L. Well, let's talk about the slope of line L. So let's go over here where nothing's really happening yet. So from here to here, which is another point that I can cleanly identify, I am rising 1 and running 2. So I can say that the slope of L is 1/2. So just like I did in the last example, I need that 1/2 times the slope of A prime to equal -1. So I'm solving for the slope of A prime. I multiply both sides by 2, and I get that the slope of A to A prime is -2/1. So from A, I'm going to go down 2/1, and then I'm going to do that again so that I'm going the same distance across line L. So here's A prime. And I'm going to use the same slope over and over again for B and C. So I'm going to go down 2/1, down 2/1. Okay, so I had to do that twice. So down 2/1, down 2/1. Here is B prime. And finally, oh, look at that. That's easy. C is in the exact same place because C is on my line of reflection. And then the last thing I have to do is connect the dots. And there's a lot going on in this diagram, so I'm going to use some color again. Here's my reflected triangle. In this example, this reflect question where they're asking you to think about what you just finished doing. It's asking how can you check that you drew the image of the triangle correctly. What I would hope that you'd realize is that a reflection is going to be a rigid motion, meaning it's going to stay the same size and the same shape, and you could measure the segments and angles and make sure that they're all the same measure, and that would help confirm that you did this correctly. In addition, you could use this definition of a reflection. You could determine that line L is the perpendicular bisector of A prime, B prime, and we don't have to worry about much with C. In this example, we're looking at reflections in the coordinate plane where we do have some numbers attached to them. And hey, look at this thing. Doesn't that look familiar? These are the observations that we made in that reflections activity. Okay, so this is kind of old news to us. We're used to this. So in example 2, they're asking us to reflect over the y-axis. And here in our table, we see that when we reflect over the y-axis, they're asking us to find the coordinates of the vertices of the image. We're being asked to reflect over the line y equals x. So when we reflect over the line y equals x, remember that's when our x and y coordinates switch places. Okay, so let me write that rule down here. And then I apply it. And once again, I know I went through that a little bit quickly, but remember that this rule is telling you exactly what to do to the x's and y's. This rule is telling me that if the point starts off as x comma y, it'll end as y comma x, meaning all I have to do for all of these points is switch my x and y coordinates. And then finally, in step 2, they want us to graph the pre-image. So 2 comma 0. 2 comma 2, 2 comma, oh, I'm sorry, I'm looking at the wrong thing, 5 comma 2, and 5 comma 1. And then they want us to kind of fill in this blank. Since DEFG lies in quadrant 1, and the quadrilateral is reflected over the line y equals x, the image will lie in quadrant what? Well, here's what they want us to think about. In the reflection over the line y equals x, none of my signs are changing. They're just switching coordinates. Also, when we talk about where something will land in the coordinate plane, you want to remember something that you probably saw in algebra, that when we're looking at the coordinate plane, once again, this is quadrant 1, 2, 3, 4. The points in this quadrant are positive comma positive, negative comma positive in quadrant 2, negative comma negative in quadrant 3, and positive comma negative in quadrant 4. Well, these are all positive positives, so these are all also going to be positive positives. So it's going to stay in quadrant 1. And then it asks me to graph that image. So E is still here. D prime is here. F prime is at 2 comma 5. And G prime is 1 comma 5. Once again, maybe some color. Take a moment and work through the your turn below this number 9. In the next example, we have the original, we have the image. We're trying to figure out where the line of reflection is. So in part A, here's the pre-image, here's the image, and the first step is to draw the segments A to A prime, B to B prime, C to C prime, and to find the midpoint of each segment. Well, there's that formula again. I told you it was important. I hope you've memorized it. And so they found the midpoint of all of those segments, and they plotted them and drew the line through them. And so that line passing through those midpoints is our line of reflection. Here they're wanting us to do a little bit more of it on our own. So they want us to start off by drawing A to A prime, B to B prime, and C to C prime. And finding the midpoints of them. Well, A is located at -3, 3. A prime is at -5, -1. So plugging into the formula, I have -3 plus -5 over 2, 3 plus -1 over 2. And when I simplify that, I have -4, 1. Oops. Next one. B is located at 2, 3. B prime at -2, -5. Finding the midpoint of them, I have 2 plus -2 and 3 plus -5. And that gives me 0, -1 here. And finally, C at 5, -1, and C prime at 3, -5. Finding the midpoint, I do 5 plus 3 over 2, and then -1 plus -5 over 2. And when I work that all out, I get 4, -3. And that's here. And as you should expect, these 3 points line up. And here is L, my line of reflection. In number 11, it's asking us how we can use a ruler and a protractor to check that line L is the line of reflection. We can use our protractor to measure the angle formed by L and the 3 segments A prime, B prime, C prime, and make sure that they are right angles. We can make sure using the ruler on our protractor to find the lengths of the parts of A prime, B prime. The next kind of problem is kind of interesting. It deals with the concept of angle in equal to angle out. So if you've ever played pool or played miniature golf and you've had to bank a shot, this is the math on that. Okay, so I want to bank this golf hole off of the line BC so that it will go into H, because I don't have a direct line that I can draw. I don't have a direct shot from the T to the hole, so I'd have to bank it. And what I want to find out is what point on line BC do I want to be aiming it for? So they're kind of talking us through this concept of angle in equal to angle out, and what we end up dealing with is reflecting H over the line BC. And we want angle 1, the angle in, to equal angle 2, the angle out, so that I'm able to make my shot. So that's what we're aiming for. We know if I'm doing a reflection that the angle formed by this and this will be congruent, because remember that reflections preserve angle measure. So that's this blank here. Because reflections preserve angle measure, angle 2 will be congruent to angle 3. And I want angle 1, therefore, to be congruent to angle 3, and this happens only, I've got to make sure that those 3 points are all in a line. So we start off reflecting H across BC in order to find the point H prime. So here's the line BC, and when I reflect, here's the line BC, and when I take the point H and reflect H over that line, here is the point H prime. It is located at 7, 4. Then they want me to draw TH and locate the point X where TH intersects BC. Okay, so from T to H prime, is there, and they intersect here, and that looks like it's approximately 6, 3.5. And so that's